Shri Gurubhyo Namaha children. Welcome to our online teaching academy Ekalaiva. Now last class I gave you the introduction about electricity and we were discussing about what is called as an electric current. Now today's class we are going to learn some very important topics related to electricity. To start with, we'll start with what is called an electric circuit. So what is an electric circuit? Now look at this diagram. This is a simple electric circuit. Now here you have a battery. Now the voltage of this battery is 6 volt and you have a resistor. I'm going to tell you in short what is called as resistance. So a resistor is connected over here and this is a bulb, and to that you connect a key and an ammeter. Now this is a very simple electric circuit, and as you all know, in the previous video I was talking about what is the direction of conventional direction of current. Look at this. Now this is the direction of current. I told you the direction of current is taken as the direction of flow of positive charges. Now here this is said to possess a high potential and this is said to possess a low potential. So the direction of current is from higher potential to a lower potential, which is just opposite to the direction of flow of electrons. Now look at here. Current direction, it moves from here to here, it comes here, but here this arrow depicts about the direction of flow of electrons. So the conventional direction of current is from positive terminal to the negative terminal, which is just opposite to the direction of flow of electrons, right? Now whenever we draw an electric circuit, now here a bulb is here, bulb is considered to be a resistor, and ammeter. We have some symbols for the electric components to be connected in a circuit. Now look at this. Now whenever we connect a cell, okay, this is how. Now this is cell. A combination of two or more cells is nothing but you call it as a battery. So these are the symbols of electric components which has to be included in a circuit. Whenever you draw a circuit, instead of drawing an electric bulb like this, okay, there is a symbol which can be used. Now when I draw this symbol, it is understood that it is nothing but an electric. Every time we cannot be drawing the diagram exactly, so we need to have some symbols. So these are some of the symbols of electric components. Let us see what it is. Now a connecting wire, it is represented like this. Then you have a rheostat that is connected to a circuit. Now this rheostat is to vary the current in a circuit, okay. So this is the electric symbol for a rheostat, or a rheostat is also otherwise called as variable resistance. And this is the symbol for an ammeter. Now an ammeter is connected in a circuit to measure the value of current, right? And similarly, this is a symbol for an voltmeter, which is used to measure potential difference, or voltage in a circuit is measured by voltmeter. And this is the symbol of a galvanometer, which is used to detect the presence of current. Whether in a circuit current is there or not is determined by galvanometer. Current is measured by ammeter. Presence of current is detected by galvanometer, and this is an open switch. Now you connect a key. Now here I have connected a key. This dot is there, no? Now this dot represents that the circuit is closed. If this dot is not there, then you call it as an open circuit. Now let's see this. It is an open circuit. The circuit is not closed. Now here this is a closed circuit. Now here I have a dot, like how I have a dot here, which means the circuit is closed, okay. So this is a closed plug key, this is an open plug key, and this is a symbol for an electric bulb. So these are some of the electric symbols that are used to just detect a electric component in a circuit, okay. Now with this we are moving on to a very important concept called electric potential and potential difference. To understand what is electric potential, let us consider a charge. Now I am going to consider a positive charge. Now this positive charge will produce an electric field surrounding it. Usually electric charges will produce electric field around it. Okay, so there is an electric field that is existing around this positive charge, right? Now I am going to take a test charge. Now test charge is plus Q naught. Now what is this charge called as? This is called as a test charge. Try to follow the content very clearly, children. Now this test charge is at infinity. So where is the test charge held at? The test charge is held at infinity. That is at a very far distance from this positive charge, right? Now what am I going to do is, I am going to bring this test charge which is at infinity to somewhere here near the electric field. Now this charge has created an electric field, right? Now I wanted to bring this test charge which is at infinity to somewhere here. Okay, now this test charge is also positive. Always a test charge is positive. Now this may be positive or negative. Okay, ma? So I am going to bring this test charge. Let us consider this position to be B, and this charge is at A. Okay, now this charge has created an electric field. Now B is in the electric field. Now I wanted to bring this test charge to B. What should I do for that? I have to do some work. Yes or no? Yes or no? So what is the amount of work done? I have to do some work to bring the test charge. Now this test charge is also otherwise called as unit positive charge. Now where is this unit positive charge held? This unit positive charge is held at infinity. So I am going to do some work to bring the unit positive charge from infinity to that point. Which point? To this point B. Okay. Now I should do the work against the electric force. Now is there an electric force? Now when I bring this charge, very near, suppose let us say that this charge is here, infinity. Now I am going to bring this charge from infinity. Now is there a force existing between these two charges? Now this is also a positive charge, this is also a positive charge. There is a force of repulsion that is existing between these two charges. As we already read in my previous video, like charges will have force of repulsion. Now I have to do the work against the electric force of repulsion between these two charges. So what is the work done is nothing but you call it as electric potential. Now as far as this charge is concerned, this charge will always have an electric potential. This charge also will have an electric potential. So what is electric potential? It is defined as the amount of work done in moving a unit positive charge from infinity to that point against the electric force. Okay, and the unit of electric potential, and I'm going to discuss electric potential difference also, then we'll discuss the unit. Okay, now again I'm going to consider the same situation. This time I'm going to have two charges plus Q at A, and here I have let me take the same test charge plus Q naught. Now this test charge is at B. Now they are separated by a distance. Okay, now what I am going to do is, again there will be a electric force between these two charges, and these two charges are held at A and B. Now what am I going to do is, I have brought this charge from infinity to this point. Now I am going to move this charge once again from B to A. Okay, now whenever we talk about electric potential is the work done to bring a charge from infinity to that point. Now whenever we talk about electric potential difference, we stick on with 2 points. Whenever we talk about electric potential difference is existing between 2 points. Now, what is electric potential is, again, it is defined as the amount of work done. I wanted to move this charge from B to A. Again, to move this charge from B to A, what should I do? I should do some work. Okay, so what is the work done? In moving a unit positive charge, this is a unit positive charge. Now this unit positive charge is at point B. I need to move this unit positive charge from point B to A. What is the work done is nothing but you call it as electric potential difference. So whenever we talk about electric potential difference, it exists between 2 points. So electric potential difference between 2 points is defined as the amount of work done in moving a unit positive charge from one point to another against the electric force. So I will have the formula for electric potential difference. So let me write here as potential difference. Potential difference is work done. So very important, work done by charge. Work done in moving a unit positive charge from one point to another against the electric force. So this is a formula, work done by charge. So potential difference is represented as V. So whether it is potential difference or electric potential, it is represented as V. So V is equal to W by Q is the formula for potential difference. Okay. Now let us write the unit for potential difference. Potential difference, the SI unit of potential difference and the SI unit of electric potential is volt. Okay, so remember, and it is also joule per, now work done is measured in joule, right? Work done, how do you measure? What is the SI unit of work done is joule, and what is the SI unit of charge? We all know that joule per coulomb is also the unit for potential difference. Okay, usually you measure it as volt. Okay, now let us take the work done is 1 joule. Okay, the work done is 1 joule. Now what is the amount of charge that is moved? It is 1 coulomb. Okay, then the potential difference is said to be 1 volt. Look at the definition here. When the potential difference is said to be 1 volt, the potential difference between 2 points, you never forget to mention this. Whenever we talk about potential difference is between 2 points. So the potential difference between 2 points is 1 volt when 1 joule of work is done in moving 1 coulomb of charge from one point to another against the electric force. This is nothing but you call it as potential difference. Very, very important definition. So I have discussed 3 definitions here, children. One is electric potential. The second one is potential difference, and what is the unit of potential difference, and when the potential difference between 2 points is 1 volt. Okay, ma. So 1 volt, I can have the formula here. 1 volt is equal to 1 joule by 1 coulomb. Is it clear? So this is the definition when the potential difference is said to be 1 volt. Potential difference said to be 1, potential difference between 2 points is said to be 1 volt when 1 joule of work is done to move 1 coulomb of charge from one point to another against, remember, always the work is done against the electric force of repulsion whenever the charges are similar. Is it clear, children? Right? Very important definition. Now, after this, we are going to touch what is called as Ohm's law. Now, this is the circuit diagram for Ohm's law. Okay? Now, this Ohm's law was established by a German physicist. His name is George Simon Ohm. Okay, so he is a German physicist. Now, he established a relation between potential difference. Now, we all know potential difference is represented as V. Okay, so he established a relation between potential difference and current. Okay, Now, so his law is named as Ohm's law. So what is Ohm's law? Now this is a circuit diagram to study Ohm's law. Now look at this. This is Ohm's law. At constant temperature. Now this is the condition. At constant temperature, the steady current. Now Ohm's law does not hold good if steady current is not given. Okay, steady current means DC. I connect the circuit to a battery. Now battery always gives DC current. Okay, so the steady current flowing through a conductor. Okay, imagine this to be a conductor. Now this is a conductor. Okay, now I allow current to pass through a conductor. Now actually this is a nichrome wire we have taken first. Okay, so you allow current to pass through a conductor. When you allow current to pass through it, the current is directly proportional to the potential difference between the ends of the conductor. Now, will there be a potential difference between these ends? Yes, definitely, because you are giving a voltage through a battery. So, the voltage what you give is directly, there will be a variation in the current, and the current is directly proportional to the potential difference. Very, very important definition. Now till you complete your 12th standard, this Ohm's law will be there with you. Okay, so very important definition, and the condition you have to definitely write. At constant temperature, the steady current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. So I proportional to V, or I can also write I by V is equal to constant. Okay, now let me take this equation. I need to replace this constant of proportionality by a constant. So I'm going to replace this by a constant called 1 by R. So 1 by R is nothing but constant of proportionality. Okay, ma? So I replace this. So I becomes now proportionality, I'm going to replace I is equal to 1 by R times V. Okay, also otherwise I bring this R to the left side. So I have IR equal to V, or V is equal to I into R. So what is this R? Okay, now this R is a constant as far as this material. Now in this diagram, now this is the resistor, right? As I told you, this is a conductor. Now what is this R is? This R is nothing but the resistance of this conductor. Now every material has got some resistance value. Now which is a constant for that material. Suppose I told you this is a nichrome wire, right? Now if this nichrome wire has got a resistance. Okay, suppose if this nichrome wire is replaced by a copper wire, definitely you will have different value of current flowing in the circuit. Now if that copper wire is replaced by an aluminium wire, definitely the value of current will be changing. So it depends on the value of current depends on what is called as resistance of this material. Okay, so resistance R is nothing but you call it as resistance of the material. Now it depends on the material what you are using. It is not the same for everyone. Every material, it is different for different material. So if you are going to change the conductor, you will have some other value of current, which is, so R is nothing but you call it as resistance of the material. Okay, or I can also write the ratio of, now I will rearrange this formula. I can also write this formula as V by I. Okay, V by I is equal to R, which means the ratio of, now here I have by anything, now here I have by, which is nothing but ratio. Okay, so the ratio of potential difference across the ends of the conductor and the current flowing through it is nothing but you call it as resistance. You need to understand these concepts very, very clearly, children. Okay, in a circuit I told you, if I replace this wire by a copper wire, there will be current. The ratio of V by I will be different. Similarly, if I replace this nichrome wire by an aluminium wire, the ratio of V by I is different, because the resistance of these type of materials is not the same. Resistance of nichrome is different, resistance of copper is different, resistance of aluminium is different. So the potential and the current, when you allow that particular material to flow through it, will not be the same. So what is this resistance? So resistance is nothing but the resistance of a conductor is defined as the ratio between the potential difference across the ends of the conductor and the current flowing through it. This is what I wrote here as V by I, ratio of potential difference across the ends of the conductor to the current flowing through it is nothing but resistance. Okay, so this resistance, now every material has got its own value of resistance. Now this resistance will oppose the flow of charges. Now I will write here resistance oppose the flow of charges in a circuit. Okay, so the resistance is different for different types of materials, and the SI unit of resistance is ohm. So V by I just wrote the formula, no, V by I is equal to R. So this unit, the unit for resistance is ohm. Okay, now if the potential difference is going to be 1 volt and if the current is going to be 1 ampere, then the resistance will be 1 ohm. So 1 ohm is equal to 1 volt by 1 ampere. Okay, so when the resistance is said to be 1 ohm, the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is maintained across its end. So when the potential difference is said to be 1 volt and the current is said to be 1 ampere, then the resistance is said to be 1 ohm. So this is about resistance, right? Now we are going on to the next topic based on resistance. Now I am going to discuss the factors on which the resistance depends on. Factors on which the resistance depends on. Okay, so the first factor resistance depends on. The first factor on which the resistance depends on is the length of the conductor. Okay, resistance is directly proportional to the length of the conductor. When you keep on increasing the length of the conductor, the resistance in that also will increase. Okay, so resistance depends on length. When length is increasing, resistance also will increase, right? The second factor, now here let me write length of the conductor. L represents the length of the conductor. Okay, ma? Now, next, resistance also is inversely proportional to the area of the conductor, area of cross section. Okay, so what is A? Area of cross section. Okay, so it has got direct proportionality with length, but resistance is inversely proportional to area. Now what does it mean? Now here, if the area is going to be lesser, suppose let us take a wire. Now here it is very thin. Okay, the area is very thin. If the area is going to be thinner, if the area is going to be lesser, what happens to the resistance? The resistance will be more. Okay, Suppose let us take a wire of thickness. Now this is the thickness when compared to the previous wire. Now the thickness of this wire is more. If the thickness is going to be more, okay, if the thickness is going to be more, now this is thinner wire, okay, thinner wire. Now this is thicker wire, okay, thicker wire has got more area, right? So if the area is going to be more, what happens to the resistance? The resistance will be lesser. So inversely proportional. This is called as inversely proportional. So resistance is directly proportional to L and it is inversely proportional to the area of cross section. Now I am going to combine these two equations. So when I combine, I will have resistance proportional, directly proportional to L and inversely proportional to area. Now I am going to replace this proportionality by a constant called rho, and now it becomes L by A. Now which is a very important equation. Now what is this rho? Rho is nothing but you call it as electrical resistivity. What is rho? Rho is nothing but you call it as electrical resistivity, and this also depends only on the nature of the material, whether it is nichrome, whether it is copper, whether it is aluminium. Each material has got its own value of electrical resistivity. So what is this rho called as? This rho is nothing but you call it as electrical resistivity. Okay, so electrical resistivity is nothing but the resistance of a conductor. If the length is, now suppose if L is going to be 1 meter and area is going to be 1 meter square, then the electrical resistivity, okay, now I can rearrange this formula. R is equal to rho into L by A, or I can also write rho is equal to R into A by L, right? Now this is the exact formula for electrical resistivity, rho. Rho, it should be written like this. Okay, so when the electrical resistivity is equal to resistance, when the length is equal to 1 meter and area is equal to 1 meter square, then I have the formula for electrical resistivity as equal to resistance. So the electrical resistivity of a material is defined as the resistance of a conductor of unit length. Unit length is if the length is going to be 1 meter and the area of cross section is going to be 1 meter square, then the resistivity is equal to resistance. Okay, and you have a SI unit for resistivity as the SI unit of resistivity is ohm meter. Okay, ohm meter. Symbol ohm is like this and M is like meter. So this is the SI unit of electrical resistivity, and it is purely depend on the nature of material. Electrical resistivity depends only on the nature of material. Okay, ma? So this is about electrical resistivity, and the reciprocal of resistance is nothing but you call it as conductance. So conductance is represented as G, which is 1 by R, whose unit is mho. The inverse reciprocal, so it is mho. And the reciprocal of electrical resistivity is nothing but you call it as electrical conductivity, which is represented as sigma. Sigma is equal to 1 by rho and its unit is per ohm per meter. Okay, so these are some of the very important terms that we discussed here. Okay, now electrical resistivity, electrical conductivity. Similarly, electrical resistance, electrical conductance. Okay, and all these electrical conductivity, electrical resistivity depends on the nature of material. So these are some of the very important concepts of today's topic. Okay, so please go through the textbook, and we will be continuing with the system of resistors in our next class. To receive our online lessons, please press the subscribe button, and you will be receiving our latest updates. Okay, so see you children for the next class.